Morning, grade 11s. Today we're going to be talking about compound transformations. So it's just graphing continued, okay? As a recall from last time, remember if I have the equation a sine k x minus d plus c, the amplitude is always the a out front. Period, remember, is 360 degrees divided by the k value. Phase shift is that shifting left to right. It's the d value, and my vertical shift is the c value on the end. So making sure you see where all of these variables are found in an original equation. Again, just recall that we don't call them horizontal shifts, we call them phase shifts, but they're the same thing. So what we're going to do is we're going to do 4 graphs today, a little more complex, and you're going to continue to practice your transformation skills of periodic functions. So the first one we want to look at is this one, 1/2 cos x plus 90. So I see that first I have no vertical transformations, up or down. So this is my midline here, the x-axis. And I know I'm going to go half a unit above and half a unit below. That's my amplitude out front. So we draw in our kind of boundary line. And remember, cosine generally starts at 0, but in this case, it's going to start 90 degrees towards the left. What you'll notice, though, is that I don't have a scale on here. Well, I have the 180, and remember, that's going to be 1, 2, 3, 4, 5, 6 degrees to get to 90. So negative 90, 1, 2, 3, 4, 5, 6, positive 90, and we'll fill in the 270 as well on each side. 6 ticks away from the 90. So just recall here that 1 tick is 15 degrees, which means 6 ticks are equal to 90 degrees. So that's just for your reference. So again, here's where I'm going to start for my function. Instead of starting at 0, I'm going to start here at negative 90. That's what my translation does, that phase shift. So starting at 90, I know that cosine starts at a maximum. So maximum, and my period is still the same. So it still takes me 360 degrees for that to happen. So maximum, middle, bottom, middle, maximum. And you'll notice that's a full revelation here from, that was a bad one, from 270 to negative 90 gives me that full revelation. I will go through and I'll plot the other points, maximum, middle, minimum, and back to the middle at 360, and I don't quite have a full cycle on this one, but that's okay. And remember, we rewrite the equation 1/2 cos x plus 90. And you're done. C'est fini. It's beautiful. Reading off this graph, the phase shift is negative 90 degrees, so that means to the left. My domain is always x is an element to the real. It's good in any x direction and y direction. But for my range, y has to be less than negative 1/2, sorry, greater than negative 1/2, and less than positive 1/2. Y is an element of the real. So we'll add some nice curly brackets on that. Beautiful. On to the next. Pause if you need a little more time to get that graph copied down. Graph 2 cycles of the following function. Okay, first thing I see is that I have a period change and I have an amplitude change, but I have no vertical shift. So this is still my midline, and I'll be going 3 units up and 3 units down. Just to kind of draw our graph out, I'm going to do 2 ticks to be 1. So that would be 1, 2, 3. It's up to you how you do that. 1, 2, 3. So it's just going to extend the graph a little bit. There's nothing wrong, though, with keeping it as just 3 ticks instead of 6 ticks down. So I'm going to say that's 1, 2, 3, just so for our reference. Okay. From here, I need to take into account my starting point, which is what I like to think of first. My phase shift is at 45 degrees. So remember, if there are 6 ticks to 90, and I'm talking about each tick being 15 degrees, I know that 45 degrees will be 3 ticks. So to the right, 1, 2, 3. This is going to be the starting point for my function. What I do want to figure out, though, is my period. Remember, period 360 divided by k, in this case, is 2. So this is 180. It means it takes 180 degrees to do one full cycle. Okay, so instead of 360, it is 180 degrees. What works nice is that if I take my period and I take the period and divide by 4, so just hold with me for a second. 180 divided by 4 gives me 45 degrees. What this gives is it gives me a scale. It gives me a really nice scale. It says that every 45 degrees something major must happen. Remember we said 45 degrees is 3 ticks. So starting at my starting point, I'm going to go 1, 2, 3, another 1, 2, 3, another 1, 2, 3. So we'll label this 45 degrees, 90 degrees. Then I'm looking at 135 degrees, 180 degrees, and 1, 2, 3, 225 degrees. At my starting point, I know that my sine function, remember sine starts in the middle. So starting in the middle, it goes middle, maximum, middle, bottom, middle. So see how making that scale of 45 degrees was really helpful? So always keep in mind that it's my period divided by 2 pi. Now it wanted 2 cycles. It doesn't matter if you go to the right or to the left. I'm going to do in my ticks, ready, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So I can fill in middle, bottom, middle, maximum, and back to the middle. So I have these 2 rotations now. I'm trying to find the same purple. And for full marks, obviously complete it and rewrite out the equation. So if there's anything you could take away from this while I'm not there to kind of reiterate today, it's about finding the scale. Every time to find your scale, you take your period and divide it by 4. The 4 is always the same. Pause if you need a second to copy that down, and we'll continue on to the next example. Here's a function, 4 cos of 1/2 x plus 90, and hopefully you already saw that I was trying to trick you. You have to factor the 1/2 out. X plus, now when you're doing 90 divided by half, that would be 180. Oh, and then there's still a minus 1. Okay. So first thing I'll do, I'm going to draw in my scale. I'll keep it the same, where I'll do 2 ticks for every 1. So I'll make this my midline. And again, that's just to kind of extend it and make my graph easier to read. And I know that I'm going to go 4 units in each direction. So this will be 1, 2, 3. But since we came from -1, that's my upper boundary. And I'm going to go 4 units down. So 1, 2, 3, 4. That's at -5. I should just write that's at +3. And I have my lower boundary. Okay. Looking for my starting point. I see I have plus 180, so it means my phase shift is 180 towards the left. Remember that 1 tick is 45 degrees, or is 15 degrees, sorry. 6 ticks is 90, so I'm looking at 12 ticks for 180. But let's just do 6 at a time. 1, 2, 3, 4, 5, 6. So that's -90. 1, 2, 3, 4, 5, 6, -180. So I have my starting point here. And I need to take into account my period before I can start. So we'll do two calculations, one for period, one for scale. 360 divided by 1/2 is 720. So that's how long it takes to do a full cycle. To figure out the scale, period, the 720 divided by 4. So notice that's never changing, that 4 on the bottom. And it says, hey, 180. So every 180 degrees, every 12 ticks, I need to kind of have a cycle going through. So I'm going to start at 180, and I'm going to go 12 ticks to the right. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. Okay. 11, 12. Cosine starts at a maximum. Up, middle, down, middle. Oh, I didn't have enough to go the next way to create a full cycle. Notice I don't have 12 ticks to the right, so I'll go 1, 2, 6, 7, 8, 9, 10, 11, 12 ticks to the left to get me back to that middle one. And notice how spread out these points are. The reason I had to go to the left is because I needed a full cycle from middle to middle. Beautiful. And you'll notice that would be from negative 720 to positive 720. Add in that extra negative 180 to get me to negative 360 there. Perfect. We're going to go on and sketch one more graph. It's a sine function, but this is kind of given to us in words. It has an amplitude of 4 and a period of this. Okay, well, I need a scale. So the first thing I'm going to do to get my scale, remember, period divided by 4. So 1080 divided by 4 to give me my scale overall of 270. So that's the scale that I'm looking for. Every 270 degrees, that's the first part from middle to top or top to bottom. It doesn't matter. It says there are no shifts. One cycle begins at the origin, and that's it. So amplitude of 4, let's go, let's say that's 1, 2, 3, 4, and negative 4 as well. 1, 2, 3, 4. Draw in your dotted line for precision. And we know that my sine function is going to start in the middle. If one tick is 15 degrees, if I'm talking 270, it means that I'm going to go 18 ticks every time. So 1 tick is 15 degrees. So therefore, I need 18 ticks to get to 270. Okay, so let's just see how this works. 1, 2, 3. Okay. So if that's just the first part there, I can see that I'm not going to have 4 of those full cycles to get to 180, so I'm going to divide it. Okay, instead of saying 18 ticks, we're going to go about halfway through that, so we'll do 9 ticks for our scale. So let's try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's 270 degrees. 1, 2, 3, 9, 1, 2, 3, 4, 1, 2, 3. Wonderful. Okay, so this is 540. Please make sure that you're labeling your scales, and this is our 270. Okay, so I get my full cycle. Sine starts in the middle, maximum, middle, bottom, middle. And I've sketched one full cycle here. So again, the scales are all whatever you would like. In terms of, in general, we make them 15 degrees. Here I made them 30 degrees, which meant I had to go half the distance. Okay. Last part, writing a function with characteristics. So this is, I would say, arguably the hardest part of this lesson, but I have faith in you. Starting off with a sine function, it has an amplitude of 3, so I'm going to stick a 3 out in front, a period of 360, which means my k value is 1, because nothing's changing. Translation 4 units down, and a phase shift of 180. So this will be x minus 180 degrees minus 4. If I look at the cosine graph, so I'm going to start off with the cosine, has an amplitude of 5, a period of 180. So that means it's half as big. So think of 360 divided by k, means k equals 2. So this is going to be 2x plus 90 plus 1. Notice here the positive and the negative. There is an option to multiply this through, but I would recommend just leaving it like this. So that's a possible equation. Okay. It doesn't say if there's a reflection, so positive or negative out front, so I'll just assume it's positive. Last part would be looking at this value, looking at these images and creating a function to match it, so sine or cosine. I'm going to do both just for practice. So let's say that this is a, let's start over here with sine graphs. Because you get to choose the equation, I get to say where I think the graph starts. Now, sine graphs, remember, start in the middle. So let's say this is my sine graph here, starting point. It goes down to -1, +1. So my amplitude out front is positive, but I'm being shifted 5 units to the right, x minus 5. And notice my midline is still at 0, so there are no transformations. If I wanted to think of it as a cosine graph, because there's no one that says it's not, remember cosines start at the top. So maybe I could say this is the starting point. There are no wrong answers. Well, there are wrong answers, but there are lots of possibilities, is what I'm trying to say. Amplitude is still 1, cosine x minus 15. And if I look at the period, because that's what I want to see here, start at 15, goes all the way down and all the way up. It takes me, that's 5 units, 5.25 here. Plus 5, and that's 2.5. So my period is 7.5 for this type of function. Now, how I would want to look at doing that is for your period, it's 360 divided by, but in this case, it would be just that. So just focusing on, instead of the period, focusing on these phase shifts here. Let's do one more. Think of it as a sine graph. Sine starts in the middle. Well, it looks like this is the middle. So let's say we start here. For my sine function, my amplitude is going 20 units above and below. I have been shifted 4 units to the right and 50 units upwards. If I look for my period, it takes 8 units for a full cycle. So this is those 8 units for a period. So what I will add there for these periods is drawing them here initially with the value here. So this is where that period value is going. So 360 divided by k, think of that, 360 divided by k equals 8. So 360 equals 8k. Which is 45. So there should be a little 45 in here. Just like if I were to do that same thing for those graphs above to find my period, because I do want to include those here. I apologize for not doing that before. It'll be 360 divided by 7.5 to give me that k value, which is 48. So both of these would have a 48 in front of them. That's what makes them a little bit tricky, is the period. Wonderful. That's the end of today's lesson. Please look ahead to work on your homework. You have the rest of the class to do that, and we'll take up any additional questions you have next week. Thanks for watching. Bye.